All right, we all know, how much data that gets generated every minute. Like, be your clicks, be your purchases, whatnot, your online views. We generate a lot of data every minute, but it's not about how much data we generate. It's about how fast we can get to the data. At the same time, how fast we can leverage the data to make sure we make smart decisions on top of it and improve and grow your business. So to follow up on what Vikram has mentioned, right? Some of the areas that we are invested from an IBM standpoint. So these are some of the 3 key investment strategic zones that we have invested on. So one is the Prismo layer, the Optimizer Plus, and the storage layer that Vikram has touched on. So as you heard from Vikram, so we just released the Prismo in our watsonx.data platform. So we definitely saw the boost it is giving to the Presto with bringing its rich C++ implementations and whatnot. We have definitely seen the CPU efficiency, the I/O efficiency, and also when you look at the columnar, rich columnar processing, and also the vectorization, we definitely see the boost that it is giving to our Presto engine. And it's just not that, right? I mean, we're also looking at, hey, how do we enhance in the space in terms of, improving the query performance overall? So we're looking at, we know that Presto has got its rich function framework, and we're trying to see how we can bridge that gap with the new enhancements that we're doing in this space. So looking at it, this is an interesting chart that we did on the performance benchmarking. And as Vikram touched on it, this is mainly on the TP-CDS benchmarking. So this is a 10 terabyte benchmark, as you see. And if you look at it, the orange dotted lines are Presto, and the blue dotted lines are the Prismo. And in the life cycle of the queries, we have definitely seen, beyond 300 CPU core utilization to finish the execution. But when we bring the same thing out of the Prismo, we're looking at in the 50 to 100x range, right? And when we look at the I/O, we're looking at 3 to 4 gigabytes per second in terms of the average I/O for Presto, and completely maxing out at 4. But when we bring this with Prismo, this is where things get really interesting. I mean, we are at 12 to 14 gigabytes per second average, and on top of it, for some of the queries, we're even going at 32 gigabytes per second. So the investments that we are doing, especially in the space, are really paying off. We definitely see the results in the performance. So, and then we're closely collaborating with Meta, and thank you for all your help. And when I took the performance ratio, right, this is again the performance ratio for the same TP-CDS benchmarking that we have done between Presto and Prismo. As you can see, most of the queries fall in the 1 to 10x range. And in some cases, it even went beyond the 10x range. So enhancements are really working out, the investments that we are making in the Prismo space. So we will continue, and we'll continue with partnering with Meta, and we'll push forward. Vikram touched on the Optimizer Plus. So think of it as a booster to your rocket engine. Whether it's Presto or Prismo, it's a complete disaggregated service, which is completely transparent to the end user. So you as an end user don't need to make any changes to your application. So all you need to do is, once you trigger the query, it goes to the coordinator node, and that's where we have the Presto plugin, and it takes that service, the query, to the disaggregated service, and that's where the magic happens. And it sends back the query back to the coordinator node, and from there, it's business as usual when it comes to the execution of the query. You may ask, what happens in the background, right? So as Vikram said, IBM has invested in the last 2 to 3 decades when it comes to the optimizer techniques or the compiler techniques, especially in the relational database and also in the warehousing space. So we are bringing some of those techniques along with it, with adding more enhancements on top of it, right? How do we be aggressive in terms of roll-up pipeline methods? How do we be aggressive in terms of reducing the redundant scan elimination? So how do we provide the rich optimizations when it comes to the runtime, right? And how do we like also save some of the compile time. So these are some of the enhancements that we are doing on top of it, not just bringing our own techniques. So we're adding on top of those techniques. So let's quickly see the numbers. So this again, another TP-CDS benchmarking that we have done, but this is on top of Prismo. So we have already done one hop in terms of performance improvement, as you can see between Presto and Prismo. This again is on top where the service is adding, as Vikram said. And as you can see, most of the queries are within the 1 to 10x range, and some queries even touched beyond that. All right, Vikram did mention about HCI system, right? Before we touch upon the last layer, the storage acceleration layer, where and how exactly we are improving and investing in terms of performance, let me take a minute to explain what is our HCI system, how it looks. So as you can see, the IBM Storage Fusion HCI system is our hyper-converged appliance, where it has all the needed infrastructure that you can run on Red Hat OpenShift container platform. So it's going to take all your complexities, take care of all your complexities when it comes to your design, your deployment, and any on-prem architectural design limitations that you might have, especially when you're trying to install IBM watsonx.data. As you can see here, the IBM watsonx.data is connected to the accelerated buckets, which are either hosted on your public cloud or your on-prem storage, on-prem setup, which is like IBM storage stuff. So in this, we do have the caching mechanism. So that is where the magic happens. So AFM is the layer that provides that caching mechanism. And you also see the multi-cloud object gateway. We all know that's a lightweight storage service that runs on OpenShift. But in this, it acts as a gateway between connecting IBM watsonx.data to the accelerated buckets that are provided by AFM. So that's the design of it. So when IBM watsonx.data reads through the data, so it goes through MCG, it goes through the AFM, and that's where the caching layer happens. So in a nutshell, if a cache hit happens, that means it's a high performance read. And if a cache miss happens, that means it needs to fetch the data from the remote bucket where the data is being hosted. So do not think of this as a traditional local caching. It goes above and beyond in terms of the caching mechanisms it provides. So once the accelerated bucket is created, so you can have, as Vikram mentioned, there are multiple engines in the IBM watsonx.data. All of those engines can leverage this data caching mechanism that is provided by AFM. So that means if one engine goes down, the other engine can still use this caching. If you want to deploy a new engine, it can come and use this caching right away. And if you want to add more policies on top, like, hey, how do I move my warm data to low-cost storage? So we can make that happen too. So there are a lot other functionalities that it brings in. So we're working on all of the enhancements. As you can see, there are two hops here. So one is we need to establish the connection between AFM and the remote buckets. And there's a connection that we need to establish between the MCG and IBM watsonx.data. So right now, all of these is manual, so we're working on completely automating it. And on top of it, if you want to bring a new bucket, right now we don't have that automation as well. So if you want to bring a new bucket where you want to convert that bucket into accelerated mode, you still need to drop and recreate. So we're working on the automation. The reason I'm giving you this background, so as you can see, we want to take this caching mechanism and make it available for the public clouds, whether it's your GCP or AWS or even IBM Cloud. And we're going to be offering that as a storage scale. So what we're going to call on the public clouds is going to be storage scale. But the beauty of it is, as you can see, we are seeing 5 to 15x of performance improvement just by enabling this cache, right? And this is a remote data. I think this one is 1 terabyte that we tested with a remote bucket on IBM COS. And we are seeing 5 to 15x performance improvement. And we're also seeing some of the queries, as you can see, more than 35, right? Which is quite phenomenal. I think the icing on the cake is not just the performance, but since it can help you get the cache from multiple engines, imagine the egress charges that you're going to save right? That's where you're going to get the biggest bang for the buck. We are looking at, in our testing, we're looking at least 30 to 40% savings in terms of egress charges. That's quite phenomenal. I mean, these are like always hidden fees that we never, right? So again, we touched on 3 areas: Optimizer Plus, Prismo, we'll continue our investment there, and storage layer, where we're currently working on making that available for public clouds. And we really thank Meta, and we also, as Vikram said, we work very closely with Intel. So Murli and team, really thank you for all the collaboration. So